Usually the first and most common way of describing multiplication or explaining what multiplication means is by using a model for multiplication of repeated sums, or we'll sometimes call this repeated addition. So the idea that if we were to add the same number over and over and over again, that's the same idea as multiplication. So for example, if we had 4 times 3, we can think of that as 4 groups of 3 each, or the number 3 4 times. And so we could think of that as repeated addition. We could think of that as that's the same thing as if I repeatedly add 3. How many times? Well, 4 times, right? So this is the same thing as 3 plus 3 plus 3 plus 3. And if we know our multiplication tables, then this is a faster way of doing 3 plus 3 plus 3 plus 3. And then even though it would give us the same answer, we would think of 3 times 4 differently than 4 times 3. So 3 times 4 we would think of as 3 groups of 4 each, right? So the first factor is the number of times that the second factor appears. So 3 times 4 I would think of as adding 4 to itself how many times? 3 times, right? So the first number is the number of times that the second number appears in my addition problem. You could also think of it as the first number is the number of groups, and then the second number is the number of objects in each group. So we'll look at an example of this. This says there are 4 bus stops and 5 children at each. How many children will be picked up by the bus? So based on this, we can say that we are repeating the number 5, right? We have 5 children, and we're repeating that how many times? We're repeating it 4 times. So this is essentially 4 groups of 5 each. So when I write my setup equation for repeated addition or repeated sums, again, my first number is the number of groups. So like 4 groups, but in this case, I'll say stops, right? Or bus stops. And then I would multiply that by the number of objects per group, which means you're always going to have that word per in your units on the second factor in your multiplication for this model. So I wouldn't just say 5 children, I would say 5 children per stop. And then since this is a setup equation, I'm not actually going to solve it yet. I'm just going to use a question mark for what I'm trying to find, which is how many children will be picked up by the bus, or in other words, how many total children are there going to be. So basically, the objects in this case are children, and the groups in this case are stops, right? And what's going to happen is the word that comes after per in the second unit is going to match the first unit, and then the units on the second factor is going to match the units on your answer. And that's always going to work that way with this model. All right, so that's our setup equation. And so one thing we could do then, if a student were struggling with how to come up with that setup equation or struggling with how to solve it from there, we would do a visual, and especially when we introduce the idea of multiplication. I can still remember my 3rd grade teacher like had groups of little apple cutouts, right? So like in this case, I have 4 bus stops, so I might just go ahead and leave spots for that. So you could even draw a street if you wanted to with these 4 stops on it. And then I know that there's 5 children at each one of these, so you could do little stick figures, or I'll just do little happy faces. Or just boxes is fine too. But we can see there's 5 children at this stop, and then I would just do that at each one. So this would give our students a nice visual of the total number of children, and we could actually count, but then again, we could also realize that we're really just adding 5 plus 5 plus 5 plus 5, and that's our repeated addition problem. But the faster way is to know 4 times 5. And then let's take a look at how we could do this also with a number line. So if your student is making a number line, they're not going to know how far out to go with your number line, right? So I would know to start at 0 just because I can't have a negative number of children. As the teacher, we would know that we want to go at least out to 20, since that's going to be our answer here. Our answer on this one is going to end up being 4 times 5 is 20 children total. But again, your student wouldn't know that, so they could just kind of, go out as far as they think they need to, and if they end up needing to go further, then they'll just erase the end and keep going. So, and then you may want to go a little bit past 20 as well, just so you're not giving away what the answer is. In this case, I kind of ran out of space, so I did just go out to 20. All right, so then in this case, we know that there's 5 children at each stop. So I would hop, but I'm going to do big hops, right? So with addition, we kind of do a hop for each one that we're adding. But for multiplication, we're going to do big hops. We're going to say, okay, start at 0. Once I go to stop number 1 with my bus, I'm going to pick up 5 kids, right? So that means here's stop number 1. And then let's go to stop number 2. So then we're going to do another 5 kids. So 1, 2, 3, 4, 5. That's going to take me to 10. So now that's stop 2. And then 5 more would get me out to stop 3, which is 15. And then finally 5 more. And you can just see where we end up. So we end up with 20. So that's our answer.